So I'm going to show you how to locate the CPU generation. As you can see, this is Intel processor, okay, and we have i3-388, okay. So the generation is the number after the dash. Dash 3 means the third generation. Always the first number is the speed or the processor frequency. The second number is the memory cache, and the third number is the speed of the FSB or front-side bus, the bus that connects the processor to the GMCH. So as you can see here in the schematic, this is IONA 478. This is the processor. Okay, here we have the front-side bus, the bus that connects the processor to the Calistoga 1466. This is the NOT bridge. Okay, so the FSB is the bus that connects between the processor and the NOT bridge. We can also know the generation of the processor using DXDiag, as you can see. So here, as you can see, we have the processor characteristics. This is Intel, as you can see, Core i3-2270U CPU, as you can see. So the dash 3 means the third generation. Always the number after the dash means generation. So we can also go and see the properties. Just go to the properties and we will find the same result. As you can see, same result. Okay, Intel Core i3-2270U CPU. As you can see here, this is the third generation. We have dash 3 means third generation. Dash 8 means this is the 8th generation. So we have 7. That means the 7th generation. Here we have dash 9, as you can see, the 9th generation. Here also dash 9. Always, as you can see, the read number, as you can see here, the number after the dash means the generation of the CPU. For the desktop motherboard, you can upgrade many parts in it, like the CPU, the graphic card, the GMCH, the HDD, the sound card, etc. But for the laptop motherboard, you cannot upgrade everything in it. You can just upgrade 4 parts. These parts are the CPU or central processing unit, the RAM, random access memory, the basic input-output system or BIOS, and the HDD or hard disk drive. So in this video, we're gonna focus on how to upgrade the CPU or the central processing unit. Okay, so let's see first the characteristic of the CPU. Basically, the CPU has 3 main characteristics. As you can see here, we have 1.83 gigahertz, we have 2M or 2 megabytes, and we have 667. I'm going to show you all these numbers means what. So 1.83 gigahertz means the speed of the processor. Okay, this is the speed or the frequency of the processor. Okay, and for 2M or 2 megabyte, this is the cache memory capacity or size. Okay, the cache memory. And 667 is the frequency or the speed of the bus that connects the processor to the NOT bridge or GMCH. This bus, we call it FSB or front side bus, that we're gonna see next in the schematic. So I will show you how to find everything about processors using just Google. For example, let's take this example. For example, for this processor, let's type this characteristics 1.83, as you can see here in the processor. So 2M or 2 megabytes and 667. Let's know what these numbers means. So let's pick the first result. Okay, so here we go. As you can see here, we have Intel Core 2 Duo processor. Okay, T5600. Okay, as you can see, we have 2M means 2 megabyte cache. As you can see, this 2 megabyte cache means the cache memory, means the memory inside the CPU. Okay, And here we have 1.83 gigahertz. This is the processor frequency or speed. Okay. And here, as you can see, we have 667 megahertz FSB. FSB means front side bus, the bus that connects the processor to GMCH. So as you can see here in the schematic or in the laptop block diagram, we have here, as you can see, we have here the processor, as you can see, Pentium M, okay, and here this is the GMCH or the NOT bridge. And as you can see, this is the FSB, as you can see, the front side bus, the bus that connects these two chips, the processor and the NOT bridge, okay? We have FSB, okay? So as you can see, we have 800, 1066 megahertz. Basically, this is its frequency, okay? We have 800, 1066 because the schematic is for another laptop, okay? So here we have FSB means the bus that connects the processor to the NOT bridge, okay? And here we have also the DMI, as you can see, direct media interface, the bus that connects the NOT bridge to the SOT bridge. Here we have its speed 100 megahertz or frequency, okay? So this is the DMI bus. Always the FSB speed is bigger, is greater than the DMI speed. Here, as you can see, we have another bus. This is the memory bus, as you can see. It connects the GMCH or the NOT bridge to the RAM, as you can see, to DDR2 RAMs. Here we have about 800, 1066 megahertz, the same frequency or speed as the FSB bus. Okay? So here, as you can see, we have 4 megabyte. This 4 megabyte means the cache memory. So this processor contains a cache memory with 4 megabytes. Okay, so if you understand this working principle, this block diagram, you can understand any laptop block diagram. Okay, so there is always 3 main characteristics for every processor. So the frequency of the processor or the speed of the processor, the cache memory, and the speed or the frequency of the FSB bus or front side bus, the bus that connects the processor or the CPU to the NOT bridge or to the GMCH. So there is another characteristics that you should pay attention is the generation, the CPU generation. So if you go to the CPU characteristics or information, you will find numbering like this. Always the number after the dash is the generation. Okay? If you find -9 means the 9th generation, -1 means the first generation, -2 means the second generation, etc. Okay? So always the number after the dash means the CPU generation. So for example, let's assume that we want to upgrade this processor with these characteristics, okay? So to upgrade any processor, you should have another processor with enhanced characteristics or performance. For example, this is just an example. Here for this processor, we have 2.10 gigahertz. Here we have just 1.83. Here, as you can see, okay? So this processor is a good processor. Here we have 3 megabytes in the memory cache. Okay, as you can see, 3 megabytes. And here we have 800 megabytes, the speed of the FSB bus. So the characteristic of this processor is greater than the characteristics of the first processor. So we can upgrade now the processor of this motherboard by removing it first. You can just unscrew the screw, as you can see. So if you focus here, you will find 2 symbols. This is lock, this is unlock. So if you turn the screw to unlock position, then you can remove the CPU easily, as you can see. Okay. To see the CPU power management circuit, as you can see, CPU power the VCC core. As you can see, this is the circuit diagram of the CPU circuit, and here in the motherboard, as you can see, this is the CPU and its circuit. So the components around the CPU are the component that is responsible to generate the VCC core. So here, as you can see, the CPU contains 2 channels. So here, this is the CPU, as you can see, that we going to study. Here we have 2 channels, inductors, as you can see, 2 inductors. Okay, as you can see, every inductor means a channel, and in the back of the CPU socket, we have other components. So this is the CPU power management IC here, okay? And this is the MOSFETs, 3 MOSFETs for the first channel, okay? And the 4 ceramic capacitors, and the other 3 MOSFETs for the second channel with the 4 ceramic capacitors, okay? So this is the back of the CPU circuit. As you can see here, many ceramic capacitors and chemical capacitors or polarized capacitors, as you can see. So this is the power management IC circuit diagram, as you can see. So this is its part number, as you can see, or reference MAX 8770. Here we have U1018, its reference in the motherboard. So let's see. So you have here U1018, as you can see, the same as we have seen in the schematic. Okay, so this is the power management IC. Here, as you can see, the first channel we have 3 MOSFETs, and in the second channel, other 3 MOSFETs. Okay, the same here in the schematic, 3 MOSFETs in the first channel. As you can see, this is the inductor, and here this is the second channel. We have 3 MOSFETs, and we have inductor. Okay, and the purpose is to generate the VCC core. Okay, as you can see, plus VCC core, the main power for the processor. The VCC core equal about 0.8 volt to 1.2 or 0.3 volts. As you can see here, for the power management IC, in order to generate the VCC core, it should receive some voltage ID. As you can see, this is IDs, as you can see, 8 ID. So this ID determine the appropriate voltage for the CPU. So for every CPU, it has its specific IDs. Okay, so based on the ID, the power management IC can generate appropriate voltage for the CPU. So as you can see here, this is the VCC and the VDD power for the power management IC. Of course, here as you can see, we have the clock, and as you can see, the power grid. Like every power management IC, it has inputs and outputs. So here, as you can see, we have 4 ceramic capacitors. This is filtering capacitors. So the 19 volt will pass through these 4 capacitors and then through these MOSFETs, and then we will get plus VCC core. So this is the 4 capacitors. This is the 4 filtering ceramic capacitors, and here we have the 3 MOSFETs that we have seen in the schematic. The same, here we have 4 capacitors and 3 MOSFETs for the second channel, as you can see. Okay, so plus VBAT, as you can see, 4 ceramic capacitors, filtering capacitor, 3 MOSFETs. Okay, as you can see, this is gate. Okay, this gate means the control signal should be applied to the MOSFET in its gate. So this is the inductor, as you can see, and here we have the plus VCC core. Here we have a diode. This is a protection component. As you can see, the diode is connected to the ground. If there is a high voltage or a high current, the diode will protect the processor. Okay, the same here, as you can see, we have this MOSFETs. This is gate. These 3 MOSFETs are activated by the power management IC. Here we have 4 ceramic capacitors. They receive the plus VBAT, the same as the first channel. The plus VBAT is always 19 volt or 20 volt. And after receiving the control signal from the power management IC, they will generate the VCC core. So this is the power management IC that generate the control signal for all MOSFETs. So this is the protection diode that is responsible to protect the CPU if there is a high tension or a high current. And the purpose here in this circuit is to get the plus VCC core for the CPU. And as I told you before, every CPU has 8 IDs. Based on the signals, the power management IC know the value of the VCC core. Okay? So now I'm going to show you the component that you should check if you have a bad motherboard and you find that the problem is in the CPU circuit. First component is the charge of the power management IC, and here, as you can see, near to the power management IC, we have some ceramic capacitors. These ceramic capacitors connected to the ground in one side and to the power management IC in the other side. So if you find any shorted capacitor, means the power management IC is bad. So this is a technique that you can use to determine whether the power management IC is good or not. Just check the continuity between the terminals of a ceramic capacitor. If you find any shorted capacitor, means the power management IC is bad. And of course you can check the VCC, the presence of the signals, the input signals like VCC, VDD, etc. So you should also check the VBAT, the 19 volt, if it is present or not. You should check the ceramic capacitors because all the ceramic capacitors are connected to the ground, as you can see. So check if these capacitors are good or not. If you find any shorted capacitor, means there is a short. Then you have to check the MOSFETs. The MOSFETs should be checked. If you find any shorted MOSFET, means the MOSFET is bad. Okay? So you should check the whole MOSFETs and the inductor. The inductor should give a continuity using the multimeter. And also the diode, the protection diode. If the diode is shorted to the ground, means the diode should be replaced. The same for this channel also. You should check MOSFETs, inductor, diode. Here in the motherboard, as you can see, we have many ceramic capacitors, so we have the IC, should be checked. We have here the ceramic capacitors around the IC. We have the MOSFET, should be checked. Okay, the ceramic capacitors, as you can see, should check it with the ground. Also here in the other channel, you should check the same component. Here we have some chemical capacitors. In the back of the socket, you should check it also. If you find any shorted capacitors, means there's a short, you should replace it. Okay? Here we have 2 inductors, as you can see, that you should check. And here we have some capacitors near to the processor.
First, let's take a look to this circuit. Here, as you can see, we have the control IC or the CPU control IC, as you can see. So its reference, as you can see here, is ISL6265, as you can see. This is its reference, okay? And over here, we have other components, okay? So, by the way, I will show you a website, a very important website that you can use anytime if you want to look for the circuit diagram of any circuit or any ICs. Okay, so for example, if we want to look for or to download the circuit diagram for this IC, you can just copy it. So let's copy the whole reference or part number, and you can just go to Google. So here we go. So let's paste here the part number and hit enter. So let's choose this result, for example. Okay, so here let's check this results. So, and as you can see here, we have the controller, the CPU controller. As you can see, we have ISL6265HRTZ. So this is a multi-output controller with integrated MOSFET drivers for AMD SVI capable mobile CPUs. As you can see, this is for CPUs. So you can just click over here. So this is the IC, as you can see here. So we have the characteristics of the IC. So you can just go here page one by one. As you can see, if I check page 2, as you can see, so this is basically the page 2. This is the functional block diagram for the IC. I mean the internal of the IC. Okay, and of course you can download its datasheet if you want. Okay, so let's go back to our schematic. So here, as I told you before, this is the CPU circuit. Okay, so the first component is the control IC, as you can see. Okay, so then we have here some MOSFETs. So this is the first channel for the CPU, and this is the second channel, as you can see. So this is the first channel, as you can see over here, and over here we have the second channel, as you can see. So this is the voltage that will be generated for the CPU. So for every CPU circuit you will find 2 channels, 3 channels, 4 or more. Okay, so this is the first channel and this is the second, and in that channel you will find, as you can see, 2 MOSFETs for each channel. So here we have 2 MOSFETs for this channel, as you can see, and also for this channel we have 2 MOSFETs, as you can see. So these 2 MOSFETs is controlled by this IC. These 2 MOSFETs are controlled by this IC. And then we have here inductor, and we have another inductor. We have here PL5 and here PL8. So basically these 2 inductors is used here as a purpose to increase the current. And then here we have electrolytic capacitors. Here we have 3 electrolytic capacitors. So these electrolytic capacitors are used to filter the current, and then we will get here the V core for the CPU. Okay, so here as I told you before, so here this is the main power, as you can see, plus V in. This is about 19 volts. So in all circuits of a computer, or exactly the laptop motherboard, you will find the main power is about 19 volt. It could be 18.5, 18 volt, 20 volt, but usually 19 volt. So in every circuit you should look for the 19 volts. Okay, so the input power is 19 volts. So this 19 volt, as you can see here, will pass through these capacitors and then will goes directly to the drain of this MOSFET. Okay, so this MOSFET will be controlled by this IC. As you can see, we have here the upper gate. Okay, and then the 19 volt will not be passed here, but the amount of voltage that will be passed is between 0.3 volt until 1.5 volt, depending of the type of the CPU, because basically the CPU usually is powered by 0.8 volt, 0.9 volts, and so on. Okay, so here we will get, for example, 0.8 volt that will be passed here through this inductor in order to increase the current, and through these 2 capacitor over here in order to fill the current, and here we will get V core, as you can see. So the same for this channel also, the second channel also the same thing. So here we have V in, as you can see over here. So the 19 volt will pass through these capacitors and then goes to the drain of this MOSFET, and then here we will get about 1 volt, 0.8 volt. This voltage will pass, as you can see, through this component directly, including the inductor, the capacitors, in order to filter the current, and we will get here the V core, as you can see. So here the purpose of this MOSFETs and this MOSFETs that are connected to the ground, as you can see here. So these two MOSFETs, as you can see, are connected to the ground. So the purpose of these two MOSFETs is to eliminate the residual voltage or the extra voltage in order to get here an exact voltage. Okay, so this is basically all about the CPU circuit. So basically the schematic is for HP Touch Smarts, okay, but the working principle is the same for all schematics and all laptops. So I hope so that you understand a little bit the CPU circuit. And please, welcome to your question. You can ask me anything about this video in the comments below, and of course you will find very useful links in the description box. And please, if you like the video, don't forget to like the video, to share it, and to subscribe if not already subscribed. And please don't forget to like the video bit, because when you like the video you motivate me to create more useful videos and content for you. And of course, for anyone who want to join me in the Patreon page, you are very welcome. There I upload every day schematics files for many laptops, and of course I can discuss and help any one of you, of my followers, in order to solve any problem you have with any laptop or computer. So thank you very much, and see you in the next video.